Hello everyone, for today's lecture video, we'll be talking about stoichiometry. Now the following objectives shall be obtained. First one is we need to define a mole. Second is describe the relationship between the mass, number of moles, and number of particles of a substance. Third is to calculate the mass, number of moles, and number of particles of a particular substance. In terms of topic outline, we have the following. First is the mole concept. Second is Avogadro's number. Third is molar mass. And fourth is mass-mole particle relationships. Apologies for the ambient noises that you may be hearing or will be hearing along the way, but nonetheless, let me continue. Mole. A mole is simply the amount of a substance that contains as many elementary entities, such as atoms, molecules, or other particles. Mole is simply a convenient way for us to express the quantity of substances containing very large number of atoms. Meaning to say, mole is simply a unit for us to quantify the amount of a substance that contains or are composed of atoms or molecules or any other particles that we may be ascribing or using or describing with on that particular substance. Now, let me repeat. Ang mole po ay, sa simpleng bagay, ay isang unit po na ginagamit para ma-quantify or mabigyan po nating bilang o measurement kung gaano kadami ang amount ng substance which contains as many elementary entities as possible, such as atoms, molecules, or other particles. Okay, so that is mole in a nutshell. A convenient way for us to express substances that contains very large number of atoms, not just atoms, but molecules and any other elementary entities. Now, what about Avogadro's number? Now, the first point indicates that the actual number of atoms in exactly 12 grams of the carbon-12 isotope was determined experimentally. And that particular number of atoms is what we call the Amedeo number. Or rather, not the Amedeo number, the Amedeo-Avogadro's number. Okay, sorry about that. It's actually the Avogadro's number. This number is known as the Avogadro's number, named after the scientist Amedeo Avogadro. Particularly or specifically, the Avogadro's number is approximately 6.022 times 10 raised to 23. So please take note, please remember and kind of memorize this one. The value for Avogadro's number or Amedeo Avogadro's number is your 6.022 times 10 raised to 23. Okay? All right. Now examples. Now how do we use or how is the Avogadro's number used? Say for example, you have 1 mole of copper. Now 1 mole of copper is equal to 6.022 times 10 raised to 23 copper atoms. Now what if you're asked 1 mole of H2O, 1 mole of water. 1 mole of water is equal to Avogadro's number and the unit will be any elementary entity. Say for example, 1 mole of H2O is simply equal to 6.022 times 10 raised to 23 water molecules. And then 1 mole of sodium chloride is equal to 6.022 times 10 raised to 23 sodium chloride formula units. In this sense, we are just applying mole concept into Avogadro's number, which means, say for example, how many atoms are there in 1 mole of not just copper, but for example, iron. If we want to convert or the conversion factor for mole to number of atoms of your iron, we simply have 1 mole of iron is simply equal to 6.022 times 10 raised to 23 atoms of iron or iron atoms. Now what about 1 mole of carbon dioxide? How many, say for example, how many molecules are there, okay? How many molecules are there in 1 mole of carbon dioxide? Now, knowing Avogadro's concept or Avogadro's number concept and mole concept, we know that in 1 mole of carbon dioxide, there's going to be 6.022 times 10 raised to 23 molecules. So in other words, we have a relationship that tells us that in every particle of a mole, there will be 6.022 times 10 raised to 23 elementary entities. Let me repeat to make things easier. In one mole, any substances, may that be of an element, a compound, okay, or an ionic compound, whatever compound that is, in every one mole, there will be 6.022 times 10 raised to 23, that is your Avogadro's number, and then elementary entities. Say, for example, how many atoms are there in one mole? Your answer will be 6.022 times 10 raised to 23. The elementary entities is just, or the word elementary entities is just an umbrella word for your atoms, molecules, what else? Formula units, and then so on and so forth. Okay? Say for example, how many molecules in one mole? Your answer will be 6.022 times 10 raised to 23. This will be your particular conversion factor if you want to know the equality or the components for your 1 mole, convert it into atoms, or 1 mole, convert it into molecules, or 1 mole into formula units. The value for your elementary entity will always be the Avogadro's number. Just like these examples. Say for example, again, you would be asked, how many atoms are there in 1 mole of copper? Your answer will be 6.022 times 10 raised to 23. If you're asked how many water molecules are there in 1 mole of H2O, your answer will be 6.022 times 10 raised to 23. This is just a particular relationship that is being imposed by the mole concept with Avogadro's number. Okay? I hope that is clear. Now, at this point, I'll be talking about a new topic, which is molar mass, the relationship now of moles and mass. Molar mass is simply the mass in grams of 1 mole of a substance. Again, molar mass is simply the mass in grams of 1 mole of a substance. This means that 1 mole of carbon-12 or carbon-12 isotope is equal to 12 grams of mass. Therefore, if we just translate the equality, the molar mass of carbon-12 therefore is 12 grams per mole. What does that mean? In Tagalog po, sa kada isang mole, kaya nga ang tawag ay o ang basa ay per mole, sa kada isang mole, mayroong 12 grams. Ito yung ibig sabihin niyang 1 mole is equal to 12 grams. Okay? Ang tawag po dito sa unit ito ay gram per mole. Ito ang magiging unit natin for molar mass. Okay? So molar mass, the unit will be gram per mole, or in Tagalog, gaano kadaming grams sa kada isang mole. Kaya nga siya gram per mole. In English lang, gram per mole, gaano kabigat kada isang mole. So say for example, this one, you have 1 mole of carbon-12 is equal to 12 grams of mass. Okay, so that will be the molar mass of carbon-12, therefore, is 12 grams per mole. Okay, so say for example, we have a different set of equality, the same rule applies. Okay, furthermore, you have here the molar mass, okay, let that be 2 capital M's. The molar mass of an element is equal to the atomic mass. Okay, so that will be your molar mass is equal to atomic mass. Okay, so whatever the atomic mass of your element, the unit is AMU, that will also be the molar mass. So let me just give you an example. Say for example, you have here the atomic mass, okay? The atomic mass of lithium is 6.941 AMU. So 6.941 AMU is found in your periodic table. So in this case, in this website, lithium has 6.94, but to be exact, we have 6.941 AMU. Since we know by definition that molar mass is equal to atomic mass, according to definition, whatever the atomic mass is, that will also be the molar mass. So therefore, lithium's molar mass is 6.941 grams per mole. So let me repeat this particular bit. Whatever the molar mass is, or whatever the atomic mass is, they are the same. So say for example, looking at the periodic table, so we have here lithium. Lithium has 6.941 AMU. Atomic mass unit is the unit for atomic mass. So whatever the value of your AMU or whatever the value of atomic mass is, that will also be the value for your molar mass. Okay? And also the other way around. If you're given with the molar mass and you were asked what is the atomic mass, you give AMU. The only difference is the unit. You have the same values. The only difference is that you have here is the unit. If you're asked for the molar mass, give this particular unit, gram per mole. If you're asked for the atomic mass, particularly provide AMU as the unit. It's that simple. Okay, so please remember, molar mass is equal to atomic mass. The unit for molar mass is your gram per mole, and then the unit for atomic mass is AMU. Okay, hopefully that is clear. Now, let us move forward to another bit, which is what we call molecular and formula mass. Now, these are two masses that are another variant from what we've discussed earlier. The molar mass of a compound is equal to the molecular mass or formula mass. So that means your molar mass, okay, let me write that one. Molar mass, the unit is gram per mole, according to definition, is equal to the molecular mass and formula mass. Formula mass. And then their unit is actually in AMU as well. So overall, whatever your molar mass is, that will also be the value for your molecular, formula, and atomic mass. Atomic, molecular, and formula mass has the same unit, which is AMU. Okay? So what is the difference? What is the difference between molecular and formula mass? So let me just define that one. Molecular mass, okay, on the other hand, is just a word or is just a term for you to use for covalent compounds. Okay? So as you learned from the previous topic all about atoms, molecules, ions, about naming covalent and ionic compound, if the compound is covalent, that means it's composed of non-metal and then a non-metal element, you will call it as covalent or covalent compound. Now, how do you name its mass? The mass will be named as molecular. Okay? Now, how about formula mass? Now, formula mass, okay, formula mass is used or a term used for ionic compounds. So, if your compound is termed to be ionic, that is composed of metal plus a non-metal element, that is termed to be ionic. Okay? Now, if it's ionic compound, ang itatawag mo sa mass niya ay formula mass. Okay? Alright, kasi ang covalent compound, ang tawag natin sa kanila ay molecules. Okay? Sa ionic compound, ang tawag natin sa kanila ay formula units. Okay? So that's the difference between the two. Let me repeat. Whatever the molar mass is, or gram per mole, parehas ang value. Pag sinabi value, yung numero. Kung ano yung numero ng molar mass mo, yun din yung magiging numero ng molecular at formula mass mo. Ang pinagkaiba lang ay from gram to mole, magiging AMU yung unit. And then furthermore, although parehas si molecular mass at formula mass in terms of unit AMU, okay, parehas po silang AMU as a unit, the difference is that how we use it as a label. Okay, parehas lang unit, okay, AMU sila, ang pinagkaiba lang ay gamit ng paglilabel. So, kung covalent ang compound mo, ang label o pangalan na ibibigay mo ay molecular mass sa kanyang bigat. Ngayon, kung ionic naman ang compound mo, ang itatawag mong label o pangalan sa kanyang mass ay formula. Okay, so that's the difference. Molecular and formula mass. Okay, so hopefully that's clear. Again, molecular and formula mass. Molecular mass is a label or word that you will use to describe the mass of covalent. And then formula mass is the label or word or name that you will be using as a description for its mass if it's ionic. Okay? Okay. Hopefully that's very clear. Alright, at this point, I'll be showing how to calculate molecular mass. First is we need to multiply the atomic mass of each element by the number of atoms of that element present in the molecule and then eventually get the sum for all the elements. Let's have an example. Calculate the molecular mass of H2O. So we need to calculate for molecular mass of H2O. So first thing is we need to account first the number of, or we need to account the atomic masses for each element. So we have here two elements. We have hydrogen and then oxygen. To know the atomic mass for each element, look at the periodic table. Hydrogen here has 1.008. So let me write only the two decimal places or the value up to two decimal places. So that will be 1.01 AMU. Again, I'm getting the value from its two decimal places. And then you have your oxygen. Your oxygen is 15.999. So I'll be getting 16.00 AMU, as I would get the rounded off up until two decimal places. The next step is multiplying each atomic masses by their respective subscripts or number of atomic mass or number of atoms. Okay, for hydrogen you have here the subscript 2, so I will put here times 2. And oxygen, automatically, if it doesn't have any subscript, that will be automatically 1. Then find their product. This will be 2.02 AMU. This will be 16.00 AMU. And then add them according to step number 2. Get the sum for all the elements. This will be 18.02 AMU. Therefore, this is my answer for the molecular mass of H2O. Okay, again, this is molecular mass because your H2O is termed to be covalent. Okay, this is a covalent compound. All right, so that is why we call the mass of H2O as, again, molecular, because H2O is a covalent compound. Again, molecular is the label, o molecular po ang pangalan dahil ang H2O po ay covalent compound. Yan po ang pamamaraan kung paano yan isolve. So looking at the solution, I actually have the same solution. Now, what if I was asked, what is the molar mass of H2O? Remember, molar mass is equal to molecular mass. Diba? A while ago, I've mentioned that molar mass is equal to molecular mass. So therefore, if I have the value 18.02 AMU, okay, if your molecular mass is 18.02 AMU, my molar mass will be 18.02 grams per mole. Let me repeat. A while ago, from the previous writings that I have, this one, okay, molar mass is equal to molecular mass and formula mass. So whatever the value for your molecular mass or formula mass is, that will also be the molar mass. So if you were asked, what is the molar mass? Now that you have the value for molecular mass, say for this one, I have molecular mass 18.02 AMU. I was asked for the mm or the molar mass. I will simply write 18.02, but the difference is the unit. I have the same values, 18.02, but I have different unit. For molecular mass, I have AMU. For molar mass, I have gram per mole. Because remember, molar mass is equal to molecular mass. Same value, different units. AMU for molecular mass, gram per mole for molar mass. Okay? So hopefully that's clear. Next one. Let me talk about how we can compute for the formula mass. The formula mass of the ionic compound has actually the same procedure with the molecular mass, the one that we had earlier. The formula mass is a sum of the atomic masses in AMU in a formula unit of an ionic compound. So, okay, so step 1, the procedure is similar with the former, with the molecular mass. So let us have an example. So let me write this one. Compute for the formula mass of sodium chloride. So sodium chloride is ionic. So this is an example of a formula unit. So first things first, we account the number of atomic masses for each element. So sodium and then chlorine. So looking at the periodic table, I have here sodium. Again, I'll be getting the value up to 2 places. So sodium will be 22.99 AMU. And then for chlorine, I'll be getting 35.45. 35.45 AMU. Second step, multiply each respective atomic masses to their respective number of atoms in the formula. So looking at sodium and chlorine, it doesn't have any subscript, so I assume that will be 1. So now I have 22.99 AMU and then 35 rather. This is 35.45 AMU for chlorine. And then add them. So adding them up, let me just get my calculator. So 22.99 plus 35.45, I have this particular answer. Again, do not forget to apply rules and measurement. Since we only do addition, or the last operation was addition, my final answer should be rounded off into least decimal place. The least decimal place among the factors that I've added is 2 decimal places, so that is why my answer is also in 2 decimal places. All right. Now, at this point, this is my final answer, formula mass of NaCl. So looking at the solution, I have here 22.99 AMU of sodium plus 35.45 AMU of chlorine. I have the final answer, 58.44 AMU for sodium chloride. Now, then again, if you were asked, what is the molar mass? Remember, molar mass is equal to formula mass. Okay, so that is your, whatever the value of your formula mass, according to this rule, that will also be your molar mass. So therefore, the molar mass for sodium chloride is also 58.44. The only difference is the unit, gram per mole. So at this point, I have formula mass 58.44 AMU, and then the molar mass is 58.44 gram per mole. Okay, so let me repeat. Again, you use formula mass as the unit or the label if you want to have it for ionic compound. And then again, as you remember from the previous topic, when we say molar mass, that is also equal to the formula mass. Same particular value, look at this one, 58.44. The only difference is the unit. AMU for formula mass, or say for example the previous one, molecular mass for covalent, and then gram per mole for molecular mass. So no need to stress about it. They have the same value, but different unit. Right? All right. Hopefully, this is clear.